Sound check first. Can anyone in the left row, you can hear me fine or? Okay. So, hi, as I said, my name is Lars. I've been active in the popularization of science in different fields, professionally and as a hobby for about 10 years. And I would like to give you some insights on how to do that, how to communicate your ideas to lay people. Because I know we have a really diverse audience, I'm trying to give every example from mathematics to history and everything in between. I hope this will be something for anyone to do. So, short outline, I will start with some introduction, obviously. Then I will tell you some techniques, how to structure your own knowledge, how to analyze the audience you're expecting, then how to overcome the hurdles you uncovered by this analysis, and of course how to find a structure for your talk. So, first of all, who are these weird lay people I've been talking about as if they were some kind of alien species? Well, obviously, we're talking about people with no academic background. So this is when you have to explain your PhD to your mother during Christmas dinner, or something like that. Or someone asks you, what are you doing in this university anyway? You know, the taxi driver. But this can be also someone with a different field. So someone who is a scientist or has an academic background, but he works just in a different field. So if you do interdisciplinary work, it is really important to be able to do that, to coordinate with someone who has a completely different background. And then there is, of course, a different specialization. With the progress of science, we all have to specialize more and more, and it is very possible that you have people in your own field who talk a very different language from you and approach problems very differently, and who, for practical terms, if you speak to them, are lay people to you. And the latter two categories are really important for practical concerns, because almost anyone who's ever going to grant you a research grant will be in these two categories. If you want to convince them to give you money, you have to be able to talk in a way they understand, because it's unlikely they will have exactly your specialization. Right? Okay. Now, the problem, as all speakers have pointed out, is one of time. This takes a lot of time, a lot of practice, and I unfortunately cannot give you a magic trick to make you perfect speakers to lay people within half an hour. So what I can do is give you some foundation for development, some basic ideas which you can use and can apply in your work to get better over time, and also humbly point out that there are such things as workshops that Piotr is organizing that I can do for you if you're interested in that, in how to communicate your science better. And the first step for this communication is not the communication part, but your science part, structuring your own knowledge. Because when we're expert in a field, we know so many facts and so many different parts of this one field that we don't even see the connections between them anymore. We are not consciously aware of them because they're so obvious to us. But to a lay person, they're not. To give you an example of a connection that I found completely obvious is the connection between breathing and matches. Right, it's basically the same, right? Well, both of them consume oxygen, and they both work on the oxidization behavior of phosphorus. Yeah, that's what the P in ATP stands for, right? But for someone who doesn't work on phosphorus chemistry, this is completely inobvious. Whereas to you, you don't even have to mention this. So you have to find a step between where you are aware of these connections and how to explain them to someone who doesn't have this knowledge. And the first step for this is just make a mind map. Sit down with a paper and a pen. For most people this works better if you actually use a paper and a pen and not something digital. And write down something from your field. This is an excerpt from my PhD thesis. You don't have to read this. Actually, in violation of what Piotr told you, this font is deliberately hard to read, so you don't do that. The point is just that there is some basic concept and the rest is connected to this. And in the end you will easily fill in a A2 sheet of paper, but you will have a deeper understanding on how the different aspects you might be talking about are connected and which of them are necessary for someone to know in order to understand what you're trying to tell them. And the next step is obviously to get a rubber duck. This is not actually a joke. Does anyone here know what rubber duck debugging is? 1, 2, 3. Okay, so that's kind of nice. So I actually have some justification to explain it again. So this is a technique in computer science, mainly writing code. If your code doesn't work, you get a rubber duck or something equally anthropomorphic and explain your code to the rubber duck, line by line. And the very act of explaining it will help you to understand what you're doing and probably help you find a mistake. And the best type of rubber ducks are, of course, students. So, if you have the ability to give private lectures, become a tutor, give lectures for a few people, help minors, in my case, for example, people who minor in chemistry. This will make you way better in your own field. This is an old adage in martial arts, that there are things in which you cannot progress beyond a certain level unless you teach them. So if you have the ability to teach something, especially if it's a small group, 3, 5 people, so people can ask you questions back, always do that. Not only do you usually get paid for this, which is nice, but you will be better in your field and you will be better at communicating it to others. So when you have this basis, you need to analyze your audience. What type of people am I expecting? Because usually you don't just start to talk about science on the streets, right? So you usually know this is coming. So there are questions like, what is the knowledge of the audience? This is kind of obvious. But it's also important, what do they find interesting? If you speak to teenagers, they have vastly different interests than adults. Or if you speak to politicians, they have completely different interests than professional scientists. And then, of course, there is such a thing as demographics. Okay, so this kind of overlaps with that. If you know you're speaking to seniors, that's a different question than speaking to preschoolers. And let's be realistic, if you know ahead of time, most of your audience will be female or male, your examples might be different. And this is something to think about beforehand. Then, of course, coming back to the knowledge part, saying that someone is ignorant is not only kind of unhelpful and rude, there are also 3 different types of not knowing something. They might know so little they can't even ask the right questions. So these are people who ask questions like, what is the melting point of prime numbers? How heavy are mirror images? Why are unicorns hollow? You know, grammatically speaking, these are questions, but they are just gibberish, they mean nothing. And for people like that, you can't start with your topic. You first have to get them to a level where they even understand the question you're researching. Then, of course, there's the trivial part that we all think of. They lack specific knowledge that we want to teach them, hence we're giving a presentation. But let's be honest, there are people who are not interested in the truth. And a common pitfall for academics is to believe this has something to do with how difficult it is what you try to tell them. And it almost never does. Let me give you 2 examples. Scientific claim A. We managed to cross 2 laser beams in a Michelson interferometer, and from the interference pattern we could calculate the gravitational wave effect from the collision of 2 black holes. This is really difficult science. You know, this is relativistic science coupled with wave optics. But if you tell that to a journalist, he will say, okay, so how do we pack this in a way that people understand it? And in the end, everyone has at least some understanding what you're doing there. Take scientific claim B. On this planet, the ice is melting. Therefore, it's getting warmer. This is much harder to explain to a lot of people. Although, from a purely scientific level, the concept of ice melting equals heat is not that difficult, right? And there is no magic bullet for this, unfortunately, for the lower part. All I can advise is be sneaky. I know for a fact that there are a lot of teachers, school teachers in the United States who teach biological evolution by never mentioning the word evolution at all. They start with genetic divergence and adaptation and changes of gene frequencies over time, and after 10 lessons they tell them, oh, by the way, what we're talking about here is evolution. Because if they start with evolution, they know no one will listen. And behind all that is something we call Dunning-Kruger effect. Who knows what Dunning-Kruger effect is? Trick question, who has perfectly understood it? Okay, so he got the joke. Dunning-Kruger effect is a psychological effect that people tend to believe themselves the more qualified in something, the less they actually know. That is because the skills you need to understand something are the very same skills you need to see the gaps and borders of your knowledge.
So it means that ignorance are the most confident.
Yes, exactly. And this is not, it does not mean to denigrate them, because we all do this. As I said, this is a general psychological effect. But what it means is, the lower you estimate the knowledge of your audience, the more diplomatic you have to be. Because the higher the risk is that you seem arrogant and looking down on them for the crime of being right. And as dumb as this sounds, this actually happens quite a lot to professional scientists. Connected but not identical to the question of knowledge is that of abstraction. As any physicist can tell you, in a first-degree approximation, a cow is a spherical symmetrical system that emits milk at a constant rate in all spatial directions. Now this is obviously a really stupid model, but it's actually kind of useful. If you want to calculate how much milk you get over a year, just assuming the milk rate will be constant is actually quite useful. You can calculate a lot of cows by assuming they're just spheres. But that is of course a level of abstraction that to most lay people is just weird. Okay? And this is of course doubly so for the queen of all abstraction, which is mathematics. Every time you talk numbers, every time you talk geometry or topology or something like that, you have to be aware that your level of abstraction might be very different from that of the audience. And often these things aren't even all that complicated, they're just abstract. And once you tell them this one abstraction step and you consciously do that, you can get a long way. And I'll be telling you how to do that later on. But we still are with analyzing the audience. And an important question is how many steps do you have to go from background knowledge to your topic? Because we are experts, it often seems to us everything is like this. There's just one step to take and you're there. In reality, it often looks more like this. There are several steps, intermediate steps that you have to get across, messages that you have to make them understand before they can understand the final topic. And you cannot do this. Problem, remember Dunning-Kruger effect, the more of the upper part you have to do, the more it must seem like the lower part. Okay? You have to make these steps flow so seamlessly into one another that they don't really feel like steps at all. What's often useful is to start with a step you know the audience already knows, because then they feel smart. And then you can go ahead without making them feel dumb. Now, to give you a short example on how easy it is to take background knowledge for granted, let me give you a historical example. Which is, assume you were a historian and you found a source. Historians like sources. And this is from the diary of Professor Smith at the University of Nimbleshire, a city I made up. And the diary reads the following. February the 13th, anno Domini 1910. Today, Mr. Jacob Cameron arrived at the seminar 20 minutes too late. He excused himself by pointing out that the tramway was delayed. I did not bother to verify his claim because I know for a fact that Mr. Cameron is an honest student. Now, let's think about what we actually learn from this source. Do we really know whether Mr. Cameron is an honest student? Probably not. Like most students want to seem honest to the professor, and we don't know how gullible Professor Smith is, right? Was he exactly 20 minutes late? Well, that seems sort of vague. I mean, it's suspiciously round number, right? So it's probably more like 80 to 22. Was it because the tramway was late? Maybe it was just a cheap excuse. Sorry. So, in any case, you already took a lot of things for granted that you didn't think about that we can actually learn from this source. So first of all, Nimbleshire had a tramway in 1910. That's not obvious. But it's obviously true from the source, otherwise the professor would have said, right, exactly, and the unicorn was delayed as well. And we also know Professor Smith wrote a diary. This might be interesting, depending on if you investigate if professors will write diaries. I don't know, but it is background knowledge that you just automatically took for granted. And taking these background steps and really writing down a list of simple bullet points, how many steps does an average audience member have to take to follow me, can be really valuable. Now once you've identified all these hurdles, the question is how do you overcome them? The first thing is the why, the how, and the what. So, typical example, what do? I do genetic sequencing. How do I do it? Well, you know, CPR, gel electrophoresis, whatever. Why do I do it? Because I want to study migration of ancestors. Okay? Now, because what we do in our everyday work, we tend to only be doing the how and what part, we tend to often forget the why. But you should always start with why. You should always tell your audience at the very first, either why do you do this or why should they be interested? The latter part can be something like a mystery. For example, the question, can we predict the future, is a good way of starting a talk about chaos theory. Because it's interesting, like everyone wants to know the lottery numbers from tomorrow, obviously. Okay? But there is a second reason for the why, which is if your audience for a moment stops paying attention, you know, the phone rings or what's too complicated, when they know why you're doing what you're doing, they will find it much easier to understand the next part, because they understand the intent of your actions. So then there is the question, how much scientific background does one actually have? Sometimes it seems that this is just a black void. Everyday people know nothing about science. Now this is flat out false. But it's also not like this. You know? They're not experts, and none of us is like this. It looks more like this, right? Universal experts don't exist anymore because the amount of knowledge has increased way beyond what a human could understand. So we all have these fields of vague interest which are really sharp in the center and may overlap with others or not, and are kind of insulated. So I, for example, am a chemist, so I know a lot about chemistry. I also find other sciences interesting. So I know a lot about certain types of physics and biology. I can tell you a lot about evolution, although not as much as an expert. I know nothing about botany. Like, botany is the science of things that can't run away. That's like my level of botany knowledge. But when you know these fields, the area that they already know, then you have a basis on which you can build. And this basis is better than most scientists tend to believe. And it's actually getting better, as hard as that seems to believe. Like concepts like percentages used to be totally weird mathematical knowledge. The placebo effect was some fringe idea in medicine. Professional pharmaceutical researchers knew that. Nowadays, almost everyone knows what a placebo effect is. And when you can build on these things, then you can not only have a starting point for your discussion, but this helps you with the second problem. Remember, overcoming abstractions. Because they already have a lot of abstract knowledge. You just have to elaborate a bit on it. Let me give you a few examples of kind of common knowledge. My favorite example is actually negative numbers, because even professional mathematicians didn't used to believe that negative numbers were a thing. Until it turned out they are super useful for finding out how much money someone owes you. I am not joking. Negative numbers were invented by financials. So things like pH, concentration, potency. This is a complicated topic. Explaining to someone why the CO2 levels in the atmosphere are high in compared to what we want to do to our climate, but really low if you might want to extract them somehow. They're still way below 1%. But there are concentrations we all understand, right? I mean, I'm in Poland. I don't have to explain to you that drinking 1 liter of wine and 1 liter of vodka will have drastically different results. And when you can find such an analogy, this is really valuable. And here, demographics are really useful. So there's something called Bayes' theorem. Who knows what Bayes' theorem is? Okay, so this is a nice set in probability calculation. It calculates depending probabilities. How likely is A if B? It's a really large formula. It's something they punish high school students with, and usually they're completely confused. I find it easy to explain. That is, I find it totally easy to explain to teenage girls. Because they all know sooner or later, most of them will ask themselves the question, how likely am I to be pregnant if the pregnancy test says positive? And suddenly this means something to them. This is not some weird thing, and you can explain, I mean, if you have older women, you can explain how likely am I to have breast cancer if the screening is positive. And it's all the same, basically. You find an example where you can actually apply this, and you work yourself back from this. You don't start with a formula that will just confuse them. Homework for tying to common knowledge. Each of you find 3 observations you could personally make to demonstrate that the world is a sphere rather than a disk. Don't tell me you could go to space, because none of you is an astronaut. And you can do this. The ancient Greeks managed this, so you can do this. So, an important thing with this tying to what they already know is the question how far you want to go. And here there is a very valuable concept called lies to children. A lie to children is a falsehood you tell someone because they're in a learning process. They don't have to literally be a child. We all learn at some point that every object has a certain weight and it always keeps that weight. And then they taught us, no, that's nonsense. They all have the same mass, but if they send you to the moon, you'll be lighter. And then they told you, no, 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 no. If you approach the speed of light, the mass actually changes as well. But you cannot explain to a 4-year-old relativistic physics. You will be tremendously unlikely to succeed in this. So you have to start with something simple and work your way up to complex. And for most practical purposes, for most lay people, being somewhere in the middle is totally fine. Let me give you an example. There is a wonderful cartoon in the Walt Disney version of Alice in Wonderland. The 1950s cartoon, I mean, not the Johnny Depp version. Okay? In that, the Mad Hatter tries to repair the watch of the White Rabbit by ripping out all the springs and gears and putting jam, butter and tea inside. Now, is anyone in this room who could actually repair mechanical clockwork? That is a no. Is everyone who didn't raise their hand, whom of you are certain that still ripping out the gears and putting tea instead into it will probably not be the right answer? So what you've just experienced is a lie to children. You are by no means qualified to repair a watch, but you at least know what the answer might look like and what is obviously total nonsense. And what you can do to do these steps is create a narrative. We already talked about this a bit, and it is really valuable, especially if you can tell a literal story. That is, stories have people in it. So you might have a real person who discovered whatever you're talking about. We love to do this. This is why we all believe that certain things have been invented or were discovered by a single person, when in fact usually it's a few dozen who work on this. Right? James Watt never invented the steam engine, just as an example. But you can also make a fictitious person, like if I go into my lab and do X, this might be an interesting way. Or you can anthropomorphize, that is, make the things human-shaped. And we do this all the time, even as professional scientists. We say that genes are selfish, when in fact, of course, genes can't think at all. This is just a metaphor. We say that gases have the innate desire to fill a volume. Gases have no desire. This is just an easy way for us to think about things. And because it's so easy, you should definitely exploit it for your presentations. And if you can, put some humor into it. I know in professional context this is often frowned upon, but it works. There's a reason why every autocratic government on this planet hates satire. Because if you can make people laugh, you can make them think. Satire works, and if you can get a joke or just a punny title into your presentation, you have already achieved quite a lot. And then there's the question of pictures. Are they worth 1,000 words? You will have noticed that there is not in fact a picture on this slide, and that is quite deliberate. Because pictures are a double-edged sword. There are things that you cannot really explain without pictures, but they can also widely distract from what you're doing. Especially if you do things like showing raw data. Showing raw data is usually not even a good idea for professional audiences. But if you do this for lay people, they will not understand anything. It will distract them totally from your message and you will not get anywhere. So if you do pictures, make them pointy and make them simplified, because that makes it easy for the audience to understand, and they have most of their brain power left to listen to you. There's a reason why children love cartoons, because cartoons don't take a lot of brain power to compute, right? So be careful with pictures. Now when you have all these basic understanding, you just need to find a structure to put this in. And this is usually the last step. Trying to work your way from slide 1 to slide whatever the last is will not work quite well. So you need a title, an interesting title. It can be a joke. It can be something shocking, like, are the bees dying out? Look at newspapers. There's a reason why newspaper titles tend to be flashy or punny or something like that. Because they want to get your attention, and you want to get the attention of the audience. Take a good start, so that people can orient themselves. And how do they do this? Start with why. Maybe you have to do some steps before you can get to the why, but it should come really early. Then you go through the exposition with everything we talked about, have good slides, tie to common knowledge, build on the background knowledge they already have, and in the end, give them a good conclusion to come home with. A take-home message that rams home your point, or whatever message you want to make. So they know what they can think about for the next few minutes they have their coffee break or something like that. And for heaven's sake, stay in the allotted time. This is already kind of unprofessional to go over time when you're talking to a professional audience. But lay people don't have the same enthusiasm for your field as you do, or they would be in your field. Right? So if you waste that time, they will not look down kindly on you. Try really hard to stay in time. So if you can do that, if you can find ways to build on the knowledge they already have, if you can find ways to overcome the distractions, to keep them entertained with a joke or an interesting story, to build a narrative, you can get them to not your level, but a level of lies to children where they will be better off afterwards, have a better understanding, and most importantly, have a functional understanding they can use to judge matters and make decisions. And when you can do all that, then you will be a great presenter. And I thank you for your attention. Do you have time for questions?
How do you differentiate biology from geography? You said that botany is a science of not thinking.
Oh, sorry, botany is the science of life forms that can't run away. My mistake. But you see how high my level of ignorance is in that. Okay? Anything else? Okay, so then I guess we go for a break.
Yes, there's coffee outside.
Yes, and should after you drink coffee and you got this magic caffeine drug we all love to consume, have questions.